For question 1, Tina was paid $5 for each parcel delivered on time. She was paid $2 for each parcel delivered late. She delivered a total of 143 parcels and was paid $544. How many parcels did she deliver on time? For questions like this, usually the method to use will be assumption method. And the way we do assumption method is to do out a table and to list down systematically. So let me show you. Let's construct a table first. Number of parcels delivered on time. Alright, this is the first column. We have the second column, which is number of parcels delivered late. And we have the last one, which is total amount paid. Now, what do I mean by assumption method? We just assume all of the parcels to be of one type. It is either you assume all to be delivered on time or we assume all to be late. So for first, let me assume all to be delivered on time, all the 143. What would that mean for the number of parcels delivered late? None. 0. And for this case, how much money would Tina be paid? We will just take 143 multiply by $5. Okay, for each successful parcel delivered on time, it will be $5. So we're going to multiply it by 5. And she would have earned $715. Which, in this case, we know that it is wrong. Because we need to achieve $544. Okay? So let's go on to figure out a pattern. Let's list it down a second time. And we do not jump around the numbers. We do it systematically. So it's 142 delivered on time and 1 delivered late. At this point, I want to mention the difference between assumption and guess and check. Guess and check means you play around with random numbers. You can try, for example, 80 over here and 63, and then the next one you try 2 over here and 141 over here. You play around with all the numbers. That is called guess and check. Then you might not know when you will guess it correctly. You probably will have to do 10 times, 50 times, or if you are lucky, once. So that is not a very effective or efficient method. However, for assumption, we start with a starting point. Over here, we assume all to be one type. And then you realize that all we need to do is 2 rows. We just need to do 2 rows to figure out the pattern. As compared to guess and check, whereby you need to do so many number of rows, you are not sure. It can be more, it can be less, but you are uncertain. Therefore, it is in not efficient method. Okay, so we're going to do assumption. We list it out systematically. So for this case, 142 and 1 deliver late. The amount paid will be 142 times $5 plus the 1 parcel that was delivered late. And the amount will be 712, which again is wrong. As of this moment, you can see the pattern emerging. Each time you decrease by 1, you increase this number by 1, it dropped by $3. One way you can look at it is that, well, if I earn 5 less and I earn 2 more, the difference will be $3, isn't it? So even without calculating, I know for a fact, for this third row, the amount will be 709. Each time is going to drop by $3 whenever I follow down the pattern. And here. So what do I do next? How do I get to the number I want? So you assume the pattern carries on. So 3 dot, the pattern continues. When will I reach $544? So from here to here, how many jumps do I need? How many repetition do I need to do? Such that minus 3, minus 3, minus 3, minus 3, minus 3 until I reach 544. Okay, so probably my next step would to be figure out the number of jumps. Okay, I use the layman term jumps. 5, so I will take 715 minus away 544 and I divide by 3. Why do I do that? First, I need to figure out the gaps between 715 to 544. That is the amount I need to close. Alright, I need to close such that it reaches 544. That is why I subtract them. And after I figure out the amount I need to jump, I divide by 3. That will give me the number of repetition I need to do. Therefore, the number of jumps is 57 times. All right, I need to do this 57 times. That means you can imagine there are 57 rows of this. You do not need to do it, write it all down, but because of this systematic listing, you know that I need to do 57 times to arrive at 544. Then how do I fill in the numbers here? I know that if I do it once, I jump once, this is 1, I jump twice, this is 2. So if I need to jump 57 times, it will be 57 here. And if it's 57 here in total, there must be 143, isn't it? What is the number here? It would be 86. Okay, let me double check. Is it 86? 80 plus 50 is 130 plus 13, 143. Yep. So what is the answer here? How many parcels did she deliver on time? 86. Okay, so I just need to write out the final step. Number of parcels she delivered on time. 143 minus 57, and I will get 86. And nothing here. Okay, let's move on. Question 2. Sally had a bag of blue marbles and a bag of white marbles. The number of blue marbles was twice the number of white marbles. Sally removed 3 blue marbles and 2 white marbles each time. After a few rounds, there were 16 blue marbles and white marble left. What was the total number of marbles Sally had at first? First, let's identify the keywords. They are at first. So usually when a question asks you to find something at first, what you should do is to work your way backwards. You can either draw the model backwards or do your table listing backwards, but what the rule of thumb is to start from the last information and work your way to the front. Let's start from the last information, which is there were 16 blue marbles and 1 white marbles left. We have blue and we have white. The number of marbles left, it's 16 Okay, again, not drawn to scale, and we have 1. Alright, moving back. Sally removed 3 blue marbles and 2 white marbles each time. For some of you, your general idea will be to sort of guess and check in a sense. Let me keep adding back the 3 and the 2. Add back the 3 and the 2, 3 and the 2, 3 and the 2 until I get a nice number such that blue is twice of white. Well, you can do that. That is assuming the answer is a small number. Then you wouldn't do many rounds of it. But what if it's a big number? What if it's 300 marbles and 160 blue marbles? Things like that. Then you can't be possibly doing the adding back until you get a lucky answer. That is not efficient. Okay. So another way to look at it is that when they mention removing 3 blue marbles and 2 white marbles, isn't this a matter of ratio? Alright, that means for every 3 blue marbles that was removed, 2 white marbles, they will also remove. So the ratio must be in the 3:2. So if we're just to look at the number of marbles removed, it must be, okay, let me separate it for a while, it must be 3:2. Again, this over here is the left. Over here, this is the removed. Okay, let me use another color. Removed. And when you combine them together, they will give you the model at first, isn't it? Make sense? Yes? Once you combine the removed and the amount remaining, you will just get the model at first. Currently, the model is not that easy to visualize, so let's rearrange. Remember, model drawing is very dynamic. As and when new information comes in, if you need to erase it, redraw it until it's better, go ahead and do it. So I'm going to do that now. I'm going to rearrange it. So I'm just going to cover everything like this. And I'm going to start from the beginning. So I remember the amount removed for blue is 3 units, and the amount removed for the white marbles 2 units, and the amount remaining for the blue marbles is something like this, 16, and we have 1. Again, not drawn to scale. So this is the model at first. What other information have we not talked about? The very first information, the very first line here. The number of blue marbles was twice the number of white marbles at first. Twice. This is twice of white. What do I mean? What if I take the white times 2? It should be equal to the blue, isn't it? So right now there are 2 units and a 1. What if I multiply it by 2? How many units will I get? I should get something like this. So I multiply it by 2, something like this, okay? Okay, something like this. So let me combine it together. I'm going to multiply it by 2. I should get this. 4 units over here and 2. This is what we can achieve with all the information. From here, is it easy to see what is 1 unit? Over here? Yes, right? We can see that 1 unit, it's simply 16 minus 2 equals to 14. Every unit here is 14. Once we have figured it out, let's erase. Again, model's drawing is dynamic. Erase the additional information and go back to the original model. This is the model at first. And we know that every single box is 14, 14, 14, 14, 14. Now we can solve it. What was the total number of marbles Sally had at first? Well, it's everything. So total number of marbles Sally had at first. 5 units, so it's 5 times 14 plus the 16 and the 1, which is plus 17. And that will give you the answer of 87. Now, in my opinion, you realize that after you practice for a while, if you were to do the past year's PSLE papers, you realize that most of the questions, the number of steps you need to get to the answer, it's not a lot. You don't have like 8, 9 steps. Generally, the bulk of your time is spent analyzing the question. Like what we did earlier, we spent quite a number of minutes analyzing the question, drawing out the model. Once you're done with the analysis, the number of steps are usually quite minimal. Alright, so that is the pattern that I've been observing, and if you practice enough, you will observe that also. Okay, so let's move on to question 3. Question 3. John and Dan had some savings each. If John gave Dan $100, both would have an equal amount of saving. If Dan gave John $100 instead, John would have 5 times as much saving as Dan. How much savings did Dan have? So let's spend some time to analyze, one information at a time. Starting from the first one, John and Dan had some savings each. So what we can draw with the first sentence is just the 2 characters, John and Dan. Moving on, second sentence, or second information. If John gave Dan $100, both would have an equal amount of saving. Now, after John had given Dan some $100, they both would have the same amount of saving. So this is what you should get after giving the $100, which is here. This $100 was given by John to Dan. So right now, let's give it back. Okay, let's cut this away and give it back. And then we can remove this. So this is the model at first. And this missing $100 here, it would mean that this must also be the $100, isn't it? Okay, makes sense, right? I'm going to shift this here, back. Alright, so if John were to give $100 to Dan, they will both have equal amount of money. So let's give it back. Alright, so second scenario. Remember, this is the model at first. Alright, John had $200 more than Dan. That is a fact at first. In another scenario, if Dan gave John, now Dan is going to give John $100 instead. John would have 5 times as much money, saving as Dan. Right now, Dan is going to, okay, let me do this. $100 somewhere here. Okay, so somewhere here, $100. Dan is going to give this $100 right now to John. Okay, before I shift this portion here, equal portion here must also be 100. So right now, Dan is going to give this 100 to John here. And then we have the missing value here. Gone. And what happens when Dan gave the $100 to, when Dan gave $100 to John? All right, again, let me show the shifting from here. Dan is going to give the 100 to John. John will have 5 times as much, 5 times, which means this must be 4 units, isn't it? Now the numbers are very nice. If this makes up the 4 units, what can we say about 1 unit? Well, it must be $100. So this is 100. This is also 100. Not to forget, we need to return back the $100 that Dan gave to John. So we're going to return this $100 back, and we remove this here. Okay, so the answer amount of savings then had is just $100 times 2 to give us $200. Question 4. A sum of money was shared among a group of boys and girls. Each boy received $4 and each girl received $2. There were 4 more girls than boys, but the boys received $32 more than the girls. What was the sum of money given to the boys and girls? Again, seems like a lot of information to process, but it's okay. With enough practice, once you build up your mathematical intuition, each time you read the question, you will know what is the approach. For this case, alright, the story goes, the boy received $4, the girl received $2. Alright, however, there are 4 more girls than boys, but even though there are more girls than boys, in the end, the girls still receive lesser. How much lesser? $32 lesser. Now, the idea behind this is, let's assume that there are equal number of boys and girls. Alright, will their difference still stay at $32? You think about it. Right now, we have, okay, maybe I can draw it out first. We have the boys, and then we have the girls. The difference between them, it's $32 for now. $32. What happens if there's an equal number of boys and girls? Since right now there are 4 more girls, right? What if I add in 4 more boys such that they have the same number? Okay, I'm going to plus 4 more boys. Plus 4 boys. What happens to the difference in the amount? The difference is going to increase, right? Increase even more, isn't it? How much more? Since each boy received $4, 4 boys, you will receive $16. So the difference is going to increase by another $16, such that the new total will be 32 plus 16, that is $48. $48 for an equal number of boys and girls. Alright, when we add in 4 more boys such that there's an equal number, the difference between them will be $48. Now, next thing to analyze. Given that there is equal number of boys and girls, can we pair them up? Since the number must stay the same, so we pair them up, 1 boy and 1 girl. When there is only 1 boy and 1 girl, what is the difference in their money? 4 minus 2, isn't it? That's $2. Is it 48? No. How about 2 boys and 2 girls? 2 boys and 2 girls, the difference in amount between them will be $4. What about 3 boys and 3 girls? 3 boys and 3 girls, the difference between them will be $6. Do you see where the pattern is going? So how many pair of boys and girls do I need to get a difference of $48? We can figure out the number of pairs of 1 boy and 1 girl. It's equal to 48 divided by 2, and we will get 24 pairs. which means there's 24 boys, there's 24 girls. Remember, this 24 boys, it's after 4 boys were added. So we need to work it back. Let's remove the 4 boys from here. So in actual fact, the actual scenario is there are 20 boys and 24 girls. So right now we can move on to the answer. The sum of money given to the boys and girls. So we know that 24, we minus away the 4 additional imaginary boys that we added in, okay? So we minus away this and then we multiply it by $4. So the 20 boys times $4, we're gonna plus the 24 girls, and each of them receives $2. So our answer will be $80 plus 48. So this is $80, this is 48. We will get $128 in total. Last thing I want to talk about it, to remind everyone, it's the main strategy for this case. It's balancing the number of boys and girls. Make them equal number. It's either you do it like me, we plus 4 boys to make it equal, or you remove the 4 girls to make them equal. If you remove the 4 girls to make them equal, the difference in amount is still going to increase, isn't it? Just it will be a different amount. Alright.